Have you ever been using an app and it just freezes? You click something and for a few seconds, nothing happens? Well, a lot of the time, the secret to preventing that is something called multi-threading. Today, we're going to unpack how Java handles this, turning what could be total chaos into smooth, efficient performance. And we'll do it by imagining we're running a coffee shop. So, here's what we're going to cover. First up, we'll look at the one barista problem. That's the core issue. Then we'll see what happens when you just hire more baristas. Spoiler alert, it can get messy. After that, we'll talk about preventing that kitchen chaos. And finally, we'll get to the really cool stuff, the efficient cafe manager and the super modern asynchronous ordering system that Java gives us. All right, so let's get right into it. Imagine a coffee shop. It's 8 a.m. and there's a line out the door. But you've only got one barista, just one person. They have to do everything, take the order, grind the beans, pull the shots, steam the milk, take the money, all for one customer before even looking at the next person. You can just feel that line getting longer and the customers getting angrier, right?
And that is precisely what happens inside your app when it's single-threaded. That one thread is our poor, overworked barista. As soon as it hits a big job, think downloading a huge file or running a really complex calculation, the entire app just stops. The UI freezes up, you can't click any buttons. It's the digital equivalent of that customer staring daggers at the barista, completely stuck.
So this really breaks it down. On the left, that's our single-threaded world. One task, then the next, then the next. A to B to C. No skipping ahead. But on the right, that's multi-threading. Now we have a team. One thread can handle the user interface, while another can be downloading that file in the background. They work in parallel. And that right there, that's the whole game. It's about doing things at the same time to keep everything moving. Okay, so the problem is obvious. One barista isn't cutting it. The solution seems just as obvious, right? Hire more people. And in Java, that's exactly what we do. Hiring a barista is just creating a new thread. Each thread is like its own little worker that can go off and do a job, splitting up the workload. Now, in Java, there are basically two ways to hire a new thread. You can extend the thread class. It's straightforward, but honestly, it's a bit rigid. See, in Java, a class can only inherit from one other class. So if you use up your one extends on thread, you're kind of stuck. That's why pretty much everyone prefers the second way, implementing the runnable interface. It's just cleaner. It lets you define the job to be done separately from the worker who's going to do it. Way more flexible.
And getting your new worker on the job is surprisingly easy. It's a three-step dance. Step 1, define the task. All the code you want to run goes inside a method called run. Step 2, create a new thread object. And step 3, and listen up. This is the most important part. You call .start, not .run. I'm serious, never call run yourself. When you call .start, you're telling the Java virtual machine, hey, I've got a new job for you. Please run this in a new thread when you're ready. The JVM then handles the magic and calls run for you.
Okay, so we've hired a bunch of baristas. The coffee is flowing, customers are happy for about 5 minutes. Because now we have a brand new problem. Total chaos in the kitchen. You've got 2 baristas trying to grab the same milk jug, 3 trying to use the one espresso machine at the same time. It's a mess. And that's exactly what happens in your code when multiple threads all try to use the same resource, like a variable or a file, at the same time. So to fix the chaos, we need a simple rule. One barista on the espresso machine at a time. That's it. In Java, we call this synchronization. Think of it like putting a lock on the espresso machine. When a thread wants to use it, it has to grab the key. As long as it has the key, no other thread can touch it. Once it's done, it puts the key back, and the next thread in line can grab it. It brings order to the chaos.
And Java gives you a few different ways to enforce this one-at-a-time rule. You can be really broad and slap the synchronized keyword on an entire method. Or, if you want to be more precise, you can just wrap a tiny piece of code, the real critical part, in a synchronized block. There's even more advanced stuff like wait and notify, which is like one barista shouting, hey, the machine's free, to another one who is waiting.
But be careful. If you set up your rules the wrong way, you can create the absolute worst-case scenario. Deadlock. Picture this. Barista A has the milk and needs the espresso machine. Barista B has the espresso machine and needs the milk. They're both just standing there, waiting for the other to give up their resource. But neither one will budge. They're stuck forever. That's a deadlock, and it will freeze your application solid.
So you can see how this gets complicated, right? Manually creating threads, managing locks, avoiding deadlocks. It's a lot of work, and it's super easy to mess up. It's like you, the owner, trying to micromanage every single barista. It's not scalable. What we need is a good manager.
And that's where the java.util.concurrent package, and specifically the executor service, comes into play. This is our café manager. Instead of you having to create a new thread for every single little job, you just give the tasks to the manager. The executor service keeps a pool of threads, our team of baristas, ready to go. It just hands out jobs to the next available worker. It's so much more efficient. And this manager has some awesome tools. For example, when you give it a task, it can give you back something called a future. Think of it like one of those little buzzers they give you at a restaurant. It represents the result you'll get eventually. Then you have things like callable, which is a task that actually gives you a result back. And there are even more powerful tools like semaphore and count latchdown for when you need to coordinate really complex jobs between your whole team of baristas.
Okay, so our shop is running pretty smoothly now. We have a team, we have a manager, but there's still one bottleneck. Customers are still clumped around the counter waiting for their name to be called. We can do even better. Let's upgrade to a fully modern, asynchronous system.
This is where CompleteFuture comes in. It's the ultimate upgrade. It's exactly like that buzzer system. The customer orders, gets a buzzer, and is now free. They can go find a seat, check their phone, whatever. They are not blocking the line anymore. And when their order is ready, the buzzer goes off. That is the core idea of non-blocking asynchronous programming. Your main thread, the one running the UI, doesn't have to wait. It can go do other things.
And what's so powerful about CompleteFuture Task is that it lets you create these beautiful automated pipelines. You can say, okay, start brewing the espresso asynchronously. Then, once that's done, automatically take that result and add steamed milk. Then, once that's done, automatically call the final step to serve it. It's a chain reaction. Each step kicks off the next one, and no one is ever just standing around waiting.
So look how far we've come. We started with that single, stressed-out barista on a one-lane road. Now we've built a multi-lane superhighway with a whole team, an expert manager, and a fully automated system. The key takeaway here is that, yeah, jumping into multi-threading can feel chaotic, but modern Java provides these incredibly powerful and elegant tools to help you manage that complexity and build truly high-performance apps.
So that really just leaves one final question for you to think about. When you look at your own code, is it built for this modern multi-lane world, or are your users still stuck in that single file line waiting for that one barista to finish one thing at a time? It's something to think about.